Hey everyone, welcome back to another edition of Can You Hack It? I am your host Ben, and this week we are on Hackthebox.eu again, taking a look at a system named Olympus. This one's a Linux box with just over a medium level of difficulty, and this one was kind of interesting because it had multiple phases to it, and so we'll see that as we go through it. But if we go ahead and pull up our terminal, and we can get an nmap started, so if we just do the normal nmap -t5, to make the timing aggressive, SC and SV to enumerate scripts and versions, lowercase v to get verbose output so we can see it as it goes, and then OA to output all formats, and we will send those to nmap/quick. And then finally the IP address of the machine, which is 10.10.10.83. And so right away we can see that port 53 is open, port 80 is open, and 2222 is open. So 53 is going to be DNS, and TCP version of DNS is generally used for transfers. So we'll take a look at that a little bit later, but it's just a good thing to keep in mind. 80 is of course going to be a web server most likely, and then 2222 is probably a remapped SSH. And so yes, as we can see, we've got 53 open, which is bind. We have 80, which is running Apache HTTPD, and then we've got 2222, which is an SSH server. Now we also notice that 22 is in the filtered state, so that's something we can pay attention to later also. That means that it is responding, but it's basically giving reset packets right away, so it's letting us know that we're not allowed to talk to it. Or sorry. I actually just told you the wrong way. If it's filtered, I believe that just means it's dropping it. It's not replying at all. Versus closed, where it gives us a reset packet. So if we go ahead and get a Gofuzz instance going just to get scanning in the background, we'll run Gofuzz with a word list. We'll use our traditional user directory medium. So it's user share word lists, dirbuster directory 23 medium, and then we'll do hide response codes of 404, which means we'll show everything else. Show full responses, which will give us the entire URL, not just the word that matched. And then recurse, so we'll actually search directories that we find. ext for extension, we'll look for PHP files, and then T for threads, and we'll do, let's say, 100. So that should be good. If we just give http://10.10.10.83/fuzz. And apparently I mistyped something. Oh, sorry. Show full responses. So it found index.php so far. So if we go ahead and fire up burp so that we can have it running in the background, and then we will manually browse the website. The reason we fire up burp is just so that we have a log of the traffic that we've sent to the server, so that if we want to check something later or play with anything, we will have it open and ready to go. So looks like we've got a picture of Zeus, or of a statue of Zeus. If we view the source, nothing too interesting. Looks like body class is Crete. Looks like we've got a style sheet. We can look at that. Looks like that style sheet has a background image of Zeus, and that's about it. So nothing super interesting there. So if we take a look at our burp instance and see if we see anything in the headers or cookies that may be interesting, just send this to repeater actually and look at it in there. So our get request is just a raw get request for the root. User agent, all that looks fine. We send that, and we look at the response, and we take a look at the headers here. It looks like we have one header that's interesting, which is xdebug, and it looks like the version's 2.5.5. So xdebug is a debugging framework that allows the remote debug of PHP code. And so it allows a user to set breakpoints, view and modify variables, or execute arbitrary code using eval commands. And basically, if it's enabled there's a couple ways it can be configured. One, it can be configured to connect to a specific IP address when somebody starts a debugging session, or it can be set with remote connect back set to true, which will tell it to connect back to any host that tries to activate a debugging session. And so what we can try and do here now is activate a debugging session and see if it will connect back to us. So what we'll want to do first and foremost is get a listener running. And so we'll do nc-lvnp 9000. And the reason I'm doing port 9000 is that's the default port that it uses to connect back onto, which we could actually look up if we, let's see, we just Google real quick for xdebug exploit. So our first link here looks like it's some Metasploit code for OS command execution with xdebug version less than 255. And so what it's showing is it allows unauthenticated OS command execution. And the way that it works basically is, let's see if I can find it in their code here, is they send, or they set a get parameter that's xdebug session start and some random alphanumeric text, which is just a identifier. That way multiple people can be debugging code on the same server at the same time, and they will have their own sessions. And so it does that start, and then further down it uses a cookie called xdebug session to identify which session it wants to be working with. And essentially what this one's doing, because it's using Metasploit, is it's encoding the Metasploit payload and then it's embedding it here. It's calling an eval. This -i1 sets the transaction ID to 1, I think. And then basically it's writing the payload to a file. It's base64 decoding the payload, or sorry, it's creating a file called file, which is going to be in the writable directory that it uses. And so it's going to write all that payload to that file, and then it's going to call system PHP and the file, and then finally it's null terminated. And so that'll basically write out the payload to a disk and then execute the payload using the PHP interpreter. So we could obviously download this payload, use Metasploit. I'm going to not do that in this case because we'll write some simple Python code that will allow us to do something similar and get our feet a little more wet. So go ahead and minimize out of that for now then. Oh, so we had our listener running. First, let's just test and see that this actually works. So we go to our headers here, we add a header, call it cookie, and then set, I think it's xdebug session. Yeah, xdebug session. And we'll just set that to some random string. It's equal to please subscribe. So we hit go. And so we see back here on our listener that we got a connection and we've got an XML blurb that's kind of letting us know that this whole session's being started. So the C data is set to xdebug. They've got version, the author, and so we'll cancel out of this for now because we're going to want to write a Python script to interact with it rather than trying to do it through Netcat, since there's difficulties like trying to send a null byte at the end of our commands. So we'll minimize out of that for right now. We'll pop open Sublime Text, we'll create a new tab, and we'll start writing some code. Now we could probably just download some code online. There's probably a million things that look almost identical to what we're going to write, but again, I think it's easier sometimes when people see how it's done. So if we import socket, and that really should be all that we need for what we're doing. I'm going to also import, or do from pipes import quote, and that'll just allow us to escape out stuff in our command if it needs to be. And so then we just need to do sock is equal to socket dot socket. Oops, sorry. Socket. And we'll do socket.af inet and socket.sockstream. And actually, let's set this type to Python so we get some color coding in case I make a obvious typo. It should be a little bit easier to spot. Socket or sock.bind, and we'll bind to 0000 port 9000, and then we'll set the listen queue to 1 while true, and then we have connection and client address, which are returned from sock.accept. And then what we'll want to do is an initial read to get rid of that initial response that it sends us when it connects, since we don't care about it. So if we do junk is equal to con.receive, and we'll just make this some big number so that we receive the entire thing. And while true, and we'll put this part in a try catch just in case. Raw input. And this will be our prompt where we type in our commands. So we do raw command, and we'll append redirect up from standard air to standard out so that we can get our error messages. And then we will package that into a command for xdebug, where we'll have it base64 encode the results that it sends back to us. And we will do a shell execute to execute our command. Format, and we'll quote out our commands in case there's any bad stuff in there. And so that should be ready to send then. So if we do a connection, send all, and eval I1, and then %s is where we're going to put our command, and then finally our null byte. And we're going to encode our command in base64. And then we'll read our response, which is going to be, let's see, connection receive. Again, we'll just do a random big number. And let's see. So what we're doing here then is we can print out the response. Now technically this code would have problems in certain things. If you had a high latency connection, for example, or low bandwidth, we might not get complete reads. In this case, our connections are pretty good. And this is just for, you know, this challenge just on a dedicated VPN connection, so I'm not super concerned about it, but that's something to keep in mind if you try and write code like this sometimes. You should always make sure that you're doing or getting a complete read that you expect before you process it, but in this case we're just going to process it right away. So if we print response, then that should be good enough to go. So if we save that, we will save it in our working directory, which is Olympus, and we'll save it as shell.py. So if we minimize this and we try and give it a run, shell.py, and it's hanging, which is good. That means it's waiting for the connection. So if we send this, we are now connected. We do an ls and it doesn't work. Comes back right away. ID comes back right away. So the fact that it's coming back right away with nothing output means we probably made a mistake. And we did. And so what you see here is this indentation. This is something that gets people in Python all the time. It's all based on indentation instead of terminators like semicolons. And so because this is indented, we actually are just getting stuck in this while true, or sorry, this try catch statement. And so we need to bring that back to that level And now we should be good, because this code all before was actually part of this except statement when it was indented that far. So if we save it, get out of that and try again, it looks like our burp is still a little hung up. Give it a second to come back to us. So now we've got our prompt back again. So now if I do ID, I get a response. You can see here in this XML blurb that there's actually a base64 encoded response. So we could parse that out using a library for Python to parse XML. I'm going to do it kind of a easier way at this point in time. Again, since this is just a quick script that we're writing, we'll copy this and we'll use it as a starting index. And so we go up here, we can do start marker is equal to that, and we can do end marker, marker is equal to that. And then down here with our response, we can do start is equal to response.find, and we can search for our start marker. And then remember, with Python or any language that I've encountered anyway, when you do a search in a string for a substring, it's going to return the index at which it found this, so the beginning part of it. So we're going to want to add in the length of start marker also, so that we get the index at which the base64 encoded string exists. And so if we do end is equal to response.find, and this time we're going to look for the end marker, and we're going to start looking at the start because we don't want to find it anywhere before the start was. And again, this could have issues if our start and end markers weren't found, but for now we'll call this good enough. So when we print our response now, we're going to want to handle it a little bit differently. We'll want to get it from start till end. And then actually, if we remember correctly, it's base64 encoded, so we'll want to decode base64. And actually, I think it's double encoded, but we'll save this. And we'll try and see what happens. So if we do ID, yeah, we're still base64 encoded. So let's decode it a second time. So we may actually not need this base64 encode up here, because I think it may automatically be base64 encoding it, but we can leave it. It doesn't really matter. So try this again. And now we can see that we are dub data, and we've got code execution on the system. And I didn't do a good job of cleaning up before, it looks like, because this ABC1ZXY shouldn't be there. I'd actually recorded this video previously, and for whatever reason, the audio didn't come through, even though it wasn't muted this time, and it was working in my test video. So I just got bad luck, I guess. And it looks like I didn't do a great job of cleaning. So let's see if I can delete this. Or rm-r-abc1zxy. Okay, so that's what it should have looked like. So we've got our Zeus JPEG, we've got our CSS, our PHP, and our fav icon. And so next what we want to do is start poking around on here and see what we can find. We could get a traditional remote shell if we wanted to, but I found that this worked well enough for this phase of the box. So if we do ls home, we see that there's a folder called Zeus. It appears to be the only account on there. So we do ls home Zeus. We see a folder called Aircrack-ng. So continue doing this. Aircrack-ng. So we can see a lot of .md files, some markup files. We can see a Docker file, or a directory called Docker file. Binaries, captured images. We've got a shell script, known pins, language strings. I think a lot of this is default for Aircrack-ng. We can look it up. Aircrack-ng. And so it looks like, yeah, pretty much everything we saw there except for that captures or captured directory is just the stock stuff that we see with Airgeddon. We could cat home Zeus Airgeddon airgeddon.sh, and apparently that gave us an issue. We had some incorrect padding, probably because that's what I was talking about earlier with the incomplete reads. My guess is airgeddon.sh is a huge file, and we ended up completing a read before we had gotten the entire file, so we tried to decode a base64 encoded object that wasn't complete. Likely we didn't even have the entire XML structure, which is fine. We'll just get another one open, and we'll continue poking around. LS home, Zeus, Airgeddon, captured. And so it looks like we've got two files in there, a captured.cap and a papyrus.txt. So if we cat home Zeus Airgeddon captured papyrus.txt, and it says captured while flying, I'll banish him to Olympia, Zeus. And so it is probably referring to Icarus, I assume. So that's probably a clue. Now the captured.cap file is likely a packet capture, and most likely a wireless packet capture since it's in this Airgeddon directory. So we'll want a way to get that back, and an easy way to do that is if we look at where we currently are. We're in www or var www.html. So we'll create a directory inside of here using put it somewhere that won't be picked up by a default word list so that we're not giving anything away to anybody else on accident. So if we make a directory in var www.html, we'll call it abc1 xcv. And so we're just making some random directory that's not likely to exist. And then if we do a copy from home Zeus Airgeddon captured and capture.cap, and we'll copy that to var www.html abc1 xcv, and then we can download that on our local machine and take a look at it. So if we pop up in our web browser, or actually let's do it from the command line. wget http://10.10.10.83/ abc1 xcv / captured.cap. I think we can open that from the command line by doing wireshark capture.cap. Give this a warning about running as root. And so we can see that this looks like a wireless capture protocols, all 802.11. We see a ton of, well, a couple things. We see an SSID called Too Close to the Sun. It's interesting that it looks more like a password where it's got some substitution of numbers in place of letters, and it's got some mixed case. And then we see a lot of deauth frames, and so that makes me think somebody was trying to capture the four-way handshake, and so they were deauthing a client. And so we can verify if we have a handshake in here by looking for EPOL. And we can see here a bunch of message 1, there's a message 2, there's message 3, and a message 4. So we do have the complete four-way handshake. So we should be able to decode this. And actually, as I think of that, well, I think I didn't clear out the old key, but that's fine. So if we try and use Aircrack, we can see if we can recover the PSK. So Aircrack-ng, and I think it's -e. We can include the SSID, although we actually don't need to. -w for word list, and we do the rocky.txt. And then the name of the file that we're going to run it against, which is capture.cap. And so you would see it do this, run through this for a while. I'm going to cancel it out since we already have it here. If I just cat it, Aircrack-ng output. And so you can see after about 7 minutes, it was able to find the key. The key is Flight of Icarus. We can actually verify that by taking the key and using it to decode the packet capture. So if we go to Preferences, Protocols, IEEE 802.11, decryption keys, we hit Edit, and this is what I forgot to clear out from last time. So key type's WPA password, key is Flight of Icarus. You'd click OK and OK. And now you'd be able to see that we can actually see the IP traffic inside of here. There wasn't a whole ton of it in this capture, and the majority of it, as far as I can tell, isn't anything useful. And so we can go ahead and close out of Wireshark now. And then what we tried to do next is we're going to try and take a look and see if we can SSH as using any of the credentials we've found. So if we do SSH, we can try Zeus at 10.10.10.83, port 2222. We can see if Flight of Icarus is his password. It's not. We can try Icarus. We can try Flight of Icarus for his password. Also not. And so then the next thing that I actually tried was, we closed out Wireshark already, was using the SSID that we had seen there, since it was kind of strange looking where it looks like it could be a password. This was kind of my one complaint about the box, is I feel like they should have had the PSK be reused as the password for Icarus. They didn't. They had the SSID be the password. So if we copy the SSID and we paste that in as a password, and now we're into the box as Icarus. Now, one thing you may notice if you were looking closely is here, actually I guess you wouldn't have noticed it because I didn't actually pull it up at all. Here our host name is 17C5, so it's this random string 17C5. Here it's a different host name. We also have a user that didn't show up over here. Over here we only had Zeus. Over here we have Icarus. So if we take a look at any of these ones, we do cat proc 1c group, and we look at the control groups. Oh, so on this one we can't because we didn't do a very good job with the read loop. So we'll do it over here instead. Cat proc 1c group. And we can see that these control groups all have /docker in the front of them. And that's actually a clue that we are running on a Docker system. There's other easy clues too. LSLA in the root, we should see a Docker env file. So in both these cases, they're running in Docker environments. So that's just something to keep in mind, is that we may have to re-enumerate on each system that we go into because they're completely separate environments. Or at least, likely to be. And so if we take a look in here then, looks like we have a file called Help of the Gods, and we are currently in Home Icarus. So this isn't where the user flag is. At first, first time I got into this box, I thought, where's the user flag? We got access on the user, which we can see here, we're Icarus, but there was no user flag. So we have to continue pushing on, see if we can figure out how to get to the user. So if we cat this Help of the Gods file and see what it says Athena goddess will guide you through the dark. Way to Rodhes is ctf Olympus.htb. And so that's interesting. It makes it sound like Rodhes is probably the next box that we need to get into, or next container, in order to get user. And ctf Olympus.htb is the only clue we have. And so if we remember from our nmap scan, we had 53 exposed on TCP, which is traditionally used for zone transfers. So what we can try and do is see if we can pull a zone transfer and get any more clues by looking at the DNS records. So if we do dig axfr ctf Olympus.htb at 10.10.10.83, And we get dig command not found. That's because in these Docker containers, they have a tendency to be stripped down and not have a whole lot of commands. So instead we can do it in our box. And we can see that it returned quickly. We were able to pull all the domain records. So we've got the start of authority. We've got some C names for Crete, Hades, Rodhes, www. We've got an A record, which points to a 192.168 address. Got a mail record. We've got a couple text records. One of them just says, here lies the Colossus of Rodhes. The other one looks a little more interesting and says, Promethus, open a temporal portal to Hades. It's got some numbers, and steal the fire. Steal the fire looks to me like it's likely a password. So my guess is Prometheus is our username and steal the fire is our password. But we need to figure out where we use those. Since we didn't see Prometheus on this system as a user, it's likely it's not through the 2222 SSH. Could be through the regular port 22 SSH that we saw that was filtered, but we would have to figure out how to get it to actually open and accept a connection. This set of numbers, if you were to combine them, is too big of a number to be a decimal representation of an IP address. So the next likely thing is that it is a list of ports that we need to knock in order to get 22 to open up. And so how that works, it's something a lot of people haven't seen before. I've seen it frequently in, people I work with have done this as a form of security in order to keep ports from being exposed until you port knock in the correct order, in which case they open up. I'm not a huge fan personally, but let's continue on, I suppose. No need to get sidetracked. So what we'll try and do is knock on port 3456, 8234, or 62431, and then see what the status of 22 is. So we can do that really easily with bash. We just do a 4x in, and then those numbers, 3456, 8234, and 62431, 2431. And then we can do nmap -pn, and we don't want to do any retries because that'll screw it up. Retry 0. Port is going to be X, and then 10.10.10.83. Done. And then once that loop is completed, we want to do an nmap. Let's see, nmap port. Just we'll look at 22 only. 10.10.10.83. And so there we go. We knocked on that port, that port, that port, and 22 is now open. And so if we go ahead and try and connect then, we can see if we can use steal the fire as the password, Prometheus as the username, and log in. So if we do SSH Prometheus, let's see if I can spell this right. Us at 10.10.10.83. And we're getting no response. We probably took too long and the port's locked back down. What we can do here instead then is make it happen at this point. SSH Prometheus at 10.10.10.83. So we knock, we connect, it prompts for a password. We give it that one, and now we are in Hades. And so from Hades, what we're going to want to do is take a look again, see what we got in our home directory. We do have a root flag here, it looks like, that we can likely access. Yeah, since Prometheus owns it, we can access it. We've got a message of the gods.txt. Do a quick look and see if we happen to be in a Docker container still, and it doesn't appear so. Yeah, and our control groups are all normal. So we're likely not in a Docker container any longer. So we cat user.txt to cut C1 through 16. And so you can see the user.txt or the user text flag there. And so now all we need to do is figure out how to get our privilege escalation. So we can get linenum or something like that down. I usually, before I do that, just take a look at a couple things, see if we can sudo anything. Doesn't look like we can. Run ID and see what groups we belong to. So we belong to a bunch of groups that don't really matter and one that could. So we belong to Docker. So that means likely Docker is running on this system, and it is, and we have permission to execute commands on Docker. So what we can try and do is do docker container ls. We can see 3 containers running here. We see Crete, which is running on port 80. So this is probably our web server. We can see Rodhes, which is listening on 53, both TCP and UDP. So that is our DNS server, and then we can see Olympia, which is listening on 2222 and redirecting to 22. And so that is that SSH server that we were able to get into. And so if we do docker image ls, we can see which images are available on this system, and it looks like there's an image called Crete, Olympia, and Rodhes. And so we can try and see if we can use Docker to get access to the root flag. I'm assuming we can't access it locally, and we can't. So what we can do is see if we can run a command on Docker, like docker run, we'll use Crete's image ID. And so what that did is it spun up Docker container using the Crete image, ran the command ID, and returned the result. And so you can see inside of Docker, we're root. So a little trick that we can do is use bind mounting to mount one volume to, or a host volume to a container. And so we can mount, say, the root directory or the root of the file system or the directory root. We can mount those to our Docker image, and then we can just poke around all we want, because although they still maintain the same permissions, so say the root flag still is only readable by root, inside of the container we are root. And so if we do docker run -v, which does our bind mount, and so we'll mount root, and we can mount it to wherever we want. It'll create it if it doesn't exist. We could mount it to just root also. Just to kind of show better what this is doing, we'll mount it to something else. I'll call it like host root, so that we can differentiate that it's the root directory on the host. It's not the Docker images root. And then if we do I for interactive, T to create or to use a sudo tty, and then Crete is the image, and bash is the command we want to run. And so you can see now that we're root at this random string, and we're in home Zeus Ergeddon, because that's the home directory of this Crete image, I guess. And so if we do ls on the root, or lsl on the root, you can see we've still got a root directory. If we ls root, nothing in there. But we've also got this host root directory. So if we cd or lsl host root, cd/host root ls, oh sorry, I typed ldl, lsl, we can see that there's one file in here, root.txt. It's owned by root, groups root, only readable by root. So if we cat root.txt, and we'll cat that to cut so you don't see the whole thing, and you can see that we're able to access the root file back on that host file system from inside the Docker container, which is one of those things you've got to keep in mind when you're running Docker, is that your permissions can get a little bit mushy. And so you want to be aware of things like doing mounts and then accessing host file systems from inside of the containers. That's all there is to this box. First video I think was better, but hey, this one was all right too. One of these days I will figure out why my mic stops working all the time. Until I do, I guess I'll just have to keep working around it. So I hope you liked the video. Give it a thumbs up if you did. Give it a thumbs up if you didn't. Go ahead and subscribe to the channel. Follow me on Twitter. Send me a message on Hackthebox if you have any questions or anything. I go by Iceman on there. And I will see you during the next video. Have a great weekend.